Hello students, in this video lesson we are going to discuss absolute value equations. Now the two bars around the x represent absolute value. An absolute value measures the distance a number is from 0. So when I have the absolute value of 3, I'm asking myself how many units away is 3 from 0? And it's 3 units away. When I have the absolute value of -3, I'm asking the same question. How many units away is -3 from 0? It's 3 units away. Now 0, the absolute value of 0 is 0 units away. And the absolute value of -22 is going to be 22 units away from 0. So the absolute value of a number, as long as that number is not 0, will be a positive value. The only number that won't be positive will be 0, because 0 is not considered positive or negative, because it's right in the middle. Now, if I have an equation, the absolute value of x equals 6, it's asking me what value is 6 units away from 0. Well, notice on the number line, positive 6 is 6 units away from 0, but so is -6. There are two answers. I've got two values that will make that a true statement. So when you have the absolute value of a letter equal to a positive number, you're going to get two answers. The very first step in solving equations that contain absolute value bars is to get the value bars by themselves. So we're going to subtract 5 from both sides. And that's going to get the absolute value of x equal to 7. Because 7 is a positive number, that tells me I'm going to have two answers. I'm going to have x equals -7, but I'm also going to have x equals a positive 7. Both of those values are 7 units away from 0. So the clue is, if your absolute value bars are equal to a positive number, you're going to separate it into two different equations, and you're going to get two different answers. Now, if your absolute value bars are equal to 0, that means you're only going to have one answer. And if, for whatever reason, if you ever got the absolute value to equal a negative number, by definition, the absolute value of a number can never be negative. So if you had the absolute value of x equals -2, you would simply have no solution, because there are no values, absolute value bars that will equal a negative number. Here's some examples. We have three equations, and we're going to solve these equations by first getting the absolute value bars by themselves. We're just going to subtract the 14 from both sides to get it to the other side of the equal sign. That will allow us to get the absolute value bars by themselves. It's equal to 0, so we know we're going to have one answer. All I have to do is get rid of the bars and solve that equation. So for this problem, the only value I'm going to have is x equals 3. 3 is the solution to the equation. The next equation, I'm going to isolate the variable by first isolating the absolute value bars. Add 2 to both sides. And I have the absolute value of x plus 4 equals a positive number. It's going to be 12. Now, because it's a positive number, I'm going to have two answers. Or I could have at least two. So let's see, I'm going to go over here. I'm going to separate that into two different equations. I know I could have the inside could equal a -12, or the inside could equal a positive 12. Because both -12 and positive 12 are both 12 units away from 0. So now I have two separate equations that I have to solve. For the first one, I'm going to add 4 to both sides. And if I do, or actually I'm going to subtract 4, and that's going to give me a negative 16. So that negative 16 is going to be one of my solutions. Over here, I'm going to subtract 4, and I'm going to get x equals a positive 8. So those are going to be my two solutions. Now my last equation, in order to get the x by itself, I'm going to have, or the absolute value bars by themselves, I'm going to have to subtract my 18. I get 3 absolute value bar, x plus 2 equals a negative 9. And then I'll go ahead and get that 3 over there. The absolute value bars of x plus 2 equals a negative 3. Because the bars are equal to a negative number, I know that's not possible, so I simply have no solution. So those are going to be the three situations that you encounter. You have equal to 0, equal to a positive number, or equal to a negative number. So let's just try some more equations now. First thing I'm going to do is I'm going to subtract my 4 from both sides. And that's going to give me the absolute value of x plus 8 equals 10. Because that's positive, I know I'm going to get two answers. So I have a x plus 8 equals a negative 10, or I'm going to have an x plus 8 equal a positive 10. Because both negative 10 and positive 10 are 10 units away from 0. So on my first one, I subtract 8, and I get x equals negative 18. And on my second one, I'm going to subtract 8, and I get x equals 2. So those are going to be my two answers for that equation. Then on to my next equation. I'm going to subtract 3 from both sides, and I'm going to get a negative number. I'm going to have the absolute value of 2x minus 5 equals a negative 1. Because by definition, absolute value bars cannot equal a negative number, I don't have to do anything else. I just simply say no solution. Now my last problem, I'm going to subtract 8, and I get 2x, the absolute value of 2x, equals 0. Because it equals 0, that tells me I'm only going to have one solution, and I'm just simply going to get rid of the bars and solve that one equation. Now if I have 0 on top, that's going to give me 0. 2 divided by 2 is going to give me a 1. It's only when it's under the line that it's undefined. This is just the value of 0. If I plug in 0 into my very top, 2 times 0 is 0, and the absolute value of 0 is 0, so I really do get 8 equals 8. Now my last equation, I don't have to get the bars by themselves because they already are, but because that's a positive 30, I'm going to have two different equations. 9x plus 3 equals a negative 30, that's one situation, or I could have 9x plus 3 equal a positive 30. Because both negative 30 and positive 30 are 30 units away from 0. To solve the first one, I'm going to minus 3. I get 9x equals negative 33. And when I divide by 9, I get a fraction. Now, some of your answers are going to be fractions, but notice that negative 33 over 9 can reduce. 3 can go into both of those. So x equals negative 11/3. That's one answer. And then I go back up here and I solve my other equation, minus my 3, and I get 9x equals 27. Divide by 9, and I get x equals 3. So you may have a fractional answer for one of yours. Sometimes they both are fractions. Those are going to be my two solutions to this equation. So go ahead and stop the video and give this a try. There's 3 there. 3 equations for you to try on your own. Go ahead and give them a try and then restart the video and check your answers. So how'd you do? This first one, we're going to add 6 to both sides, and we're going to get the absolute value of x plus 4 equals 28. Because that's positive, that means I'm going to have 2 different equations. So I'm going to separate that. X plus 4 equals negative 28. That's one equation. And I'm going to have x plus 4 equals a positive 28. That's going to be the other equation. So on the first one, I'm going to subtract my 4. And I get x equals negative 32. And then on the other one, I'm going to subtract my 4. And I get x equals positive 24. Those should have been your 2 answers. For the second middle equation, I'm going to subtract my 6. And I get the absolute value of x minus 2 equals a negative 3. Since absolute value can't be equal to a negative number, that's simply no solution. And then over here on my last one, I'm going to add 6 to both sides. And I have the absolute value of 3x plus 5 equals 26. Now 26 is positive, so that tells me 2 answers. 3x plus 5 equals negative 26, or 3x plus 5 equals negative 26. Now I'm going to solve both of these. 5, 3x equals negative 31, divided by 3. And I get negative 31 thirds. That's one answer. It doesn't reduce. Now I go over here and I solve the other equation. And I get 3x equals negative, this is a negative, this should have been positive. So that's going to give me a positive 21. And I'm going to divide by my 3, and I'm going to get x equals a 7. So I have x equals negative 31 over 3, and x equals 7. Those are the 2 answers you should have got. Now sometimes we have an absolute value bar equal to another absolute value bar. When we have something like this, we're going to separate these into 2 equations, because we know absolute values are either going to be positive or 0. So I'm going to separate this into x minus 4 equals the opposite of 6x plus 1. And I'm also going to just get rid of the bars and set the x minus 4 equals to 6x plus 1. Those are going to be my 2 equations that I'm going to have to solve. So when you have a absolute value bars equal to another expression within absolute value bars, you're always going to have 2 equations. One of them is going to be the opposite of what's inside. And then the other one is going to be just get rid of the bars altogether and solve it. So when I solve this, I'm going to distribute that negative. So I have x minus 4 equals negative 6x minus 1. Now, in order to solve this equation, all the x's have to be on one side and all the constants have to be on the other side. So I'm going to add 6x to both sides. And I'm going to get 7x minus 4 equals negative 1. Now I have to add my 4 to both sides. So I'm going to add my 4, and I get 7x equals 5. And then I'm going to divide by 7, so I get x equals 5/7. So that's one answer. Now to find my other answer, I go down here, and I do the same thing. I get the x's on one side, so I'm going to minus my 6x. I always like to move the x's to the left and numbers to the right, but you could go, doesn't matter. So I have negative 5x minus 4. Those are opposites, so they're gone, equals 1. Now I'm going to add my 4 to both sides. And I get negative 5x equals 5. And then I'm going to divide by negative 5. And I'm going to end up getting x equals negative 1. So those are my two answers for that particular equation. X equals negative 1 and x equals 5/7. I wouldn't say it's like disappearing on me. So let's go to our next equation. We're going to have x minus 2 equals the opposite of x plus 9. That's going to be one equation. And then I'm going to have them simply as they are with no absolute value bars. X minus 2 equals x plus 9. I always like to do the opposite one first because we're always conditioned to do left to right, smallest to largest. So I'm going to distribute my negative, and I'm going to get x minus 2 equals negative x minus 9. Now I'm going to add x to both sides. X is on the same side, and I'm going to add the 2 to get the constants on the other side. So I get 2x equals a negative 7. And so then I'm going to divide by 2, and I get x equals negative 7/2. So that's one answer. Now I have to go down and do the other equation. Now notice here, when I try to move my x's to be on the left-hand side, they both are canceled. I get negative 2 equals a positive 9, which is false. So that means this is not going to give me another solution. I do have a solution because up here, this one worked. But this particular equation only has one answer because the other equation didn't give me an answer. This last situation, I'm going to again say x plus 4 equals the opposite of 7 minus x. That's my first equation. And then my second equation would be x plus 4 equals 7 minus x. Those are my two equations that I'm going to try to solve. My first one is I'm going to distribute my negative sign. And I'm going to move my x's to the same side. But they cancel out, don't they? And I get a negative 4 equals a negative 7. So that's not going to give me an answer. It's false, so that's just not going to give me an answer. So I go on to my next one to see if it will give me an answer. And on this one, when I add my x's to both sides, they don't cancel. I get 2x plus 4 equals 7. Now I'm going to subtract my 4 from both sides. And I get 2x equals 3. And then I'm going to divide by my 2. So I'm going to get x equals 3 over 2. So that's going to be my only solution. So that is the video lesson on solving equations containing absolute values. I hope this was helpful. Have a great day.